Now let's look at the construct of Lambda. There are two different constructs. So one is the infrastructure part and the other one is the execution part. So when I talk about the execution part, that is essentially the code execution. In our case, we'll write code using Python. So I'll tell you how the Python execution is handled in Lambda. But before that, we need to know the infrastructure part. So if we plan to execute our code using Lambda, what are the other things that are needed? This is where I introduce you to Lambda function. And Lambda function is the wrapper which provides the execution environment for code. And when I say execution environment, it is both the infrastructure part and the code execution part. So let's look at it step by step. First is the infrastructure part. And what is this Lambda function? What are the things that are there in the Lambda function? It is essentially a wrapper for a lot of things. All these things are combined together to create a Lambda function. Now, first thing is, of course, the code. In our case, it would be a Python code. We write a code, upload it to S3, or we can write a code in the Lambda console itself, and Lambda will execute that particular code. While creating the Lambda function, we also provide the infrastructure part. Now, when I say infrastructure, I mean resources. And when I mean resources, it is nothing but memory and CPU. The amount of memory that you can provide or provision for a single Lambda function is minimum 128 MB and the maximum is 10 GB. And you'll get corresponding amount of CPU. You cannot mention the number of CPUs that you want. What AWS Lambda would do, it would provision corresponding number of CPUs, which is proportionate to the amount of memory. You can look at EC2 instance type. You'll get to know how many CPUs or how many vCPUs you'll get if you provision, let's say, 1 GB of memory. How many vCPUs you'll get if you provision, let's say, 10 GB of memory. So if you look at the EC2 instance type and find out an instance with, let's say, 8 GB of memory, you'll get to know how many vCPUs are there, and you'll get equivalent number of CPUs in Lambda also, depending on the memory that you configure. So if I configure 128 MB of memory, I'll get very less amount of CPU. If you configure 10 GB of memory, then of course the number of CPUs would be more. Then we provide temporary storage also, and it can be from 512 MB to 10 GB. Now this temporary storage is a storage which is available for the programs. So let's say you are writing a program, in which case you have to store certain amount of temporary data in your disk. There can be programs wherein you have to write certain data to disk and read it from the disk back again. And if you want temporary storage, Lambda will give you that, whose minimum value is 512 MB and maximum is 10 GB. And all these things are wrapped using Lambda function. I'll show you how we can create a Lambda function. Another crucial component of Lambda function is the IAM permissions or IAM roles. Now, why do we need IAM permissions or IAM roles? Because in the previous slide, I had told you that Lambda has integration only with AWS services. So let's say you upload a file and you want to read data from that file, and then you want to write the process data back to S3. So in this case, you need to have read permission from S3 and write permission to S3. So for that, you need an IAM role, and that is the IAM permission or IAM role I'm talking about. So these are the service roles which a Lambda function would need if the function wants to read from S3 or Kinesis or SQS, etc. Then we have the other infrastructural part like VPC. VPC is the virtual private cloud, and we have to provide the subnetwork also, security group also. Along with that, we can provide environment variables also. So environment variables are the ones which are sent to the program from the environment. It is similar to the Python OS library, wherein you'll use the OS library to get the environment variable and assign the value to a Python variable. Now, one of the most important things is the trigger. And trigger is when you want this Lambda function to execute the code that you have provided. As I have told you that Lambda is used for event driven processing only, meaning that you can execute the code only when there is an event that has happened in S3. I will talk about the events which are relevant in data engineering, as you cannot use Lambda to execute any code continuously. You need certain triggers. That's the event. And triggers tell you when the code will be executed. Whenever an event happens, that is the trigger, and then the code would be executed. The code is the one that you have uploaded or given to Lambda function. And these are the different triggers which are available in Lambda for data engineering. Of course, there are a lot of other triggers which are available, but those are not relevant for data engineering. We have S3, which is the most common use case. If you are uploading an object or uploading a file or deleting a file, you want to do some very lightweight processing automatically. So in that case, you would create a trigger for S3 so that the Lambda function gets executed whenever you upload a file. Once the processing is done, maybe you want to do something. You want to send some message to SQS or to Kafka, or you want to write some record to DynamoDB. All those things can be done. So S3 is one trigger. The other trigger is SQS. Kafka or MSK is another trigger, and DynamoDB is another trigger. So SQS and Kafka are more or less similar. And in this case, what would happen whenever, let's say, certain number of messages are available either in SQS or in Kafka or MSK, then you want to do some processing, lightweight processing again, not distributed processing. You want to do some lightweight processing. So in that case, you can mention SQS and Kafka as Lambda function trigger also. And there are triggers for DynamoDB streams. DynamoDB, as you might already know, is an OLTP database on AWS, and whatever changes that you do on DynamoDB, those are written in DynamoDB streams. You can actually execute a Lambda function whenever certain number of data is available in DynamoDB streams. So these are the different triggers. We have S3, DynamoDB, SQS, Kafka, and MSK. I have not seen Lambda getting used in conjunction with Kafka or Kinesis or MSK for that matter. I have mostly seen Lambda getting used with S3 and SQS. Not too many data engineering apart from these services. One of the major use cases is S3. Whenever there's an event in S3, you want to execute the code in Lambda automatically. So one of the use cases is if you are, let's say, uploading an object or a file to a bucket or a folder, that is one event. Or you are copying an object or a file from one folder to another folder, that can be another event. Or let's say you are deleting objects from a folder or a bucket, that can be another event. So whenever these events happen, you want to make sure that some processing happens automatically, and this is where you can use Lambda. I'll show you hands-on using this, but this is just one of the use case. Now before going further, of course, it is time to show you the Lambda console and how you can use Lambda. What are these different components that I have talked about in this Lambda function? So as I already told you that Lambda function is a wrapper to keep the code and provision resources also. Let us go ahead and see that.